Hi, my name is Rachel Howard. I'm from Columbus State University, and today I'm going to be discussing how designated land use can affect E. coli levels in stream systems. Land use is often described as the way humans use land. Most of the designated land usage is defined by its type, area, structure of buildings, and impervious surfaces. Human activity has a major impact on the environment, whether it's positive or negative. The utilization of the land around us is constantly changing, and with each designated use, there are specific and cumulative effects on the air and water quality, watershed function, generation of waste, climate, human health. Land use is often classified into 7 different categories. The urban or developed land use combines residential areas, commercial and industrial sites, or really any area that is considered built-up land. The agricultural category is composed of crops, vineyards, feeding compounds, and farms. The rangeland category mostly involves a mix of rangeland with shrubs and brush. The forest, water, and wetland categories are relatively straightforward as far as like evergreens, streams, lakes, non-forested wetlands, things like that. And the 7th category is the barren land use, and this is mostly made up of beaches, bare rocks, and gravel pits. When assessing the different land use categories, both the urbanized and agricultural types pose the greatest environmental threat. As population rises, an increased need for developments and food sources are made. This creates a domino effect of increased use of impervious surfaces, which contributes to non-point source pollution, and it can also affect the peak flow and stormwater runoff. When urbanized runoff enters our stream systems, it carries a combination of dirt, oils, toxic compounds, and nutrients from fertilizers. Such contaminants have serious impacts on the surrounding environment. The use of land for agricultural needs is also increasing as the demand for food is rapidly heightened as the population is booming. This land use can greatly impact the quality of the surrounding water as well as an increased runoff from pesticides, fertilizers, and nutrients from manures, which will infiltrate our water supply. As I stated previously, contaminants of all kinds can enter our stream systems and severely degrade our environment, and some have great impacts on human health. E. coli is a rod-shaped bacterium that is a member of the fecal coliform group. It's typically found in gastrointestinal tracts and feces of warm-blooded animals. E. coli can enter a stream system through stormwater and agricultural runoff. It can also enter through sewage overflows and malfunctioning sewer systems. The presence of E. coli in a freshwater system will directly indicate that there's evidence of fecal contamination. The EPA recommends that a safe level of E. coli should remain at or less than the rate of 126 colony-forming units per 100 milliliters of sample. If the bacteria exceeds that level of safety recommendation, those with direct contact can face a series of potential health problems, such as urinary tract infections, respiratory illnesses, pneumonia, etc. To maintain a better understanding of potential sources of fecal contamination in streams, I conducted a study which would allow me to investigate if specific land use types directly influence the level of E. coli present in stream systems. I predict that the land use designated as land development or urbanization will possess the greatest influence on E. coli contamination in the streams. There was a series of methods that I conducted within this study. I began by downloading my data from various databases. I converted the downloaded raster images and converted them to vector files to provide a better quality of analysis of the data. I combined the land use data using joins and intersects, and then was able to create a land use map specifically for the Chattahoochee watershed. This map allowed me to locate appropriate sample sites and then analyze my data. To begin this study, I began by collecting data from the Georgia Clearinghouse database. Within this search engine, I was able to narrow down the layers that pertain to my research. Once I found the land use data set that would best suit my assessment, I was easily able to extract it into ArcMaps. The map on the left is the raster image that I uploaded in ArcMaps from the Georgia Clearinghouse. I began reclassifying the raster image to make the data more suitable to work with and easier to understand. I then converted my reclassified raster dataset to polygons. This will allow me to better manipulate the data and conduct a more precise analysis. The map on the right is the image created after the raster was converted into polygons. Once my raster file was converted to polygons, I was able to begin to layer the other shapefiles like states, countries, and watersheds on top of this new one. I condensed the land use data into 5 categories: barren, forested, urban, wetlands, and agriculture. There are 2 other categories that are used for classifying land use, but these 5 are more appropriate for this particular study. I'm focusing on the watershed within Georgia, but more specifically the Chattahoochee River watershed. To make sure I was able to focus on the Chattahoochee watershed, I used a series of tools within ArcMap to remove the unnecessary data from the other watersheds, but keep the land use data for the Chattahoochee in place. Once I was able to get all of the land use data for the Chattahoochee watershed, which you can see on the right, I began to analyze the data based on the individual land use attribute tables. Once I knew which portions of the watershed were classified under which land use, I was able to analyze the data to get a better understanding of what percentage of each land use covered the watershed. The pie chart on the right of the slide provides a good visual of how much each land category covers the watershed. As you can see, the watershed is covered of about 60% of the forested land use, and the urban land use holds the second largest coverage with about 20 to 25% coverage. After analyzing the quantity of land coverage per use, I was able to then choose my E. coli sample sites based off these values in the designated areas. A local nonprofit organization called Chattahoochee River Keepers has an amazing interactive database that stores all of their collected data from sample sites. The map at the top is an overview of what their home map looks like. Within each of the points, there are a variety of individual sample sites. Water samples are carefully extracted from the designated locations and then transported to one of 3 labs for analysis. In the labs, they are measured for total coliform groups and E. coli levels. All of the data is uploaded onto the map, and they even offer a way to download the historical data from each site. By using my land coverage map of the Chattahoochee, I was able to choose a sample site that was located within each land use category at its greatest percentage of coverage. I extracted the data from 5 sites into an Excel document. From there, I was able to calculate the average total coliform and E. coli levels from January 2020 to January 2021. By looking at the table, you can see that all of the sample sites are way above the EPA recommended rate of 126. The closest E. coli rate is surprisingly agriculture, and there's no surprise that the highest is urban, which is almost 14 times greater than the safety recommended rate. Now that I had all of my data, I could run a statistical analysis between E. coli levels and designated land use sites. I found that there were no significant differences between the sites and E. coli levels. Therefore, my hypothesis that the land use designated as land development will possess the greatest influence on E. coli contamination was not supported by this study. I feel like this project could be improved by analyzing more sample sites within each land use, or even comparing the sites after rain events to get a better understanding of runoff influence on the E. coli levels.